Hello, I've got my friends Godzilla and Sharktopus here to help us talk about Fractions Bite, a little bite of fractions for your day. Fractions are weird because let's be honest, fractions are kind of weird. So what do I mean by weird today? Well, there are a lot of things that are weird about fractions, but the one we're going to talk about today is the answer to a question that one of my students asked. And it's a really reasonable and actually very thoughtful question. If you watched the previous video in the series, or even if you didn't and you've just been working with fractions, you'll see that various fractions are equal to each other. So in the previous video, we had 1/2 equals 4/8, or 4/8. And the student asked me, why do you have fractions that are equal to each other? Why do you want more than one fraction that equals something? And the answer is, one, that yes, fractions are definitely weird, but fractions aren't the only numbers that do this. So let's take a look at some other numbers that do this. I picked 2 times 3 equals 6. So we have two different expressions that are equal to each other. 2 times 3 is an expression. It's a product. And 6 is technically the result of taking that product. 6 can also be referred to as the product of 2 times 3. And it is also a number. It's a particular kind of number. I mean, it's a natural number. It's an integer. It's a rational number. It's even a real number. It falls into a lot of categories. So there are a lot of ways we can talk about 6. These two expressions are equal. And later on in algebra, you'll learn about a concept called substitution, where if you've got two things that are equal, you could use one in place of the other, kind of like twins. If you've ever seen a hilarious sitcom where there are two twins and they keep taking each other's place, that's kind of like what math is, but with less of a laugh track. So let's take a look at why would we have two different ways to talk about 2 times 3 equals 6? Well, we have to check for context. So I've written a couple of sample problems. The first problem says evaluate 2 times 3. Now, if I actually ask you, if I say, hey, what's 2 times 3? You would give the answer. You would say 2 times 3 equals 6. And so the answer you would give was the single number 6. And you're showing that you know your times tables or you know how to use a calculator. I could also, in number 2, ask you to express 6 as a product of 2 prime numbers. So what does that mean? Well, if it's a product, that means we're multiplying. 2, there are 2 of them. Prime numbers. Prime numbers are numbers that can only be divided by themselves and 1 and get an even answer. So 2 examples are 2 and 3, and 2 times 3 equals 6. So if I want you to express 6 as a product, you'd say, oh, 6 equals 2 times 3, but the answer you'd give me was just the 2 times 3 part. And each of these answers is useful in different situations. So it's really nice that we have 2 ways to express the number which is equal to 6. So let's move back to fractions. Now, when we go back to the fractions, there's actually a rule that is pretty much the rule. And that is, if you're dealing with fractions, always reduce as far as you can unless you're asked not to. Well, that's great. So the rule is always true except when it's not. Good going, math. Yay, math. Well, so let's talk about this. There's got to be a little flexibility because sometimes we're actually not interested in reducing the fraction. We want to do something else. You know, lots of flexibility. Math is basically a set of agreements, and we're going to agree that all of these statements are true. And then within that, what can we build? We can build all of these different interesting structures out of it. So let's look at the first problem. if I ask you straight up, I say, I've got the fraction 6 over 20, let's reduce it. Okay, well, so then you would sit down and think about it. And if you have 6 over 20, you'd see, oh, I could divide each of them by 2. 2 goes into 6, 2 goes into 20. You could cancel and you would get 3 over 10. So your answer for this problem is actually the reduced form 3 over 10. And if you're not sure there, stop for a second, think about it. Let me take a little space over here. Let's see, how do I want to write this? So maybe I'll take the space right here. If I have 6 over 20, I could write the 6 because we just did that work, 2 times 3. And then 20 can be written as 2 times 10. And then I say, oh, wait, the 2 and the 2 match. I'm allowed to cancel top to bottom things that match. So that equals 3 over 10. So this is the reasoning for why I said that right here, just so you have the notes written in case you weren't sure where that came from. So if I ask you to reduce a fraction, you should definitely reduce it. Now, why did I stop at 3 over 10? Nothing that goes into 3 nicely goes into 10 nicely. 3 goes into 3, but 3 does not go into 10 nicely. So we leave it there. That's in its simplified form or its most reduced form. Okay, next up, what if I ask you to multiply 2 fractions? Okay, well, you may not have gotten up to this because we haven't covered this in the videos yet, although I hope to. But basically the rule is when you're asked to multiply 2 fractions, it's a really, this is the best. Addition, avoid for a little bit till you get good at this. But multiplication, you could do right now. You're going to multiply across the top. And you're going to multiply across the bottom. Multiplication of fractions is very quick to pick up. As I said, addition and subtraction and even division, those take a little bit of practice. So I'm not going to give examples like that. But multiplication, you can see, 1 times 6, the tops multiply, the bottoms multiply. And if you're not already sick of the numbers, wait a minute, 1 times 6 is 6, 4 times 5 is 20. Oh my goodness, we came up with the same fraction again. Now, even though I asked you to multiply the 2 fractions, I am going to expect that you're going to, either in your head or on the paper, because, different people like to do their work differently, you're going to go ahead and go through this process that we did up here automatically. I won't actually necessarily even say reduce your answer. I may. Some books are nice and they're like, hey, you should reduce. And some books are like, hey, you should just know to reduce. So just remember to reduce. So either way, you want to reduce. Notice the problem doesn't say it. Always give your answer in a reduced form, except when you shouldn't. And I know that's the part where everyone's like, seriously? And the thing is that the problem will be written in a really interesting way. So you'll notice something different is happening. With this one, I'm asking you to solve this equation. I've got 3 over 10 is equal to something over 20. This is another way of saying I want you to raise terms. And so what we do here, just like we talked about in the last video, is if I'm going to go from 10 to 20, I think, what did I do to go from 10 to 20? The rule here, notice all of these are all about multiplication. So 10 times what number gives me 20? 2, you got it. So if I'm multiplying 2 on the bottom, remember, fractions have balance top to bottom. So I also have to multiply by 2 on top. Okay, so 3 times 2 is 6. 10 times 2 is 20th. And either your answer would be 6 over 20, or you might, depending on exactly how it's written, you might also do 6, because that's what belongs here in the question mark. Notice that this problem, I specifically want you to keep it fluffed up like this because I started with 3/10. Yes, I know that's the reduced form. I want to know what the form looks like when it's over 20. So hopefully this answers a couple questions. Basically, the answer is in math, tons of stuff equals tons of other stuff. And it just means you get more options. When you're answering a problem, you're going to have a lot of options, and the trick is going to be at figuring out which is the answer that you want to choose. And if you're ever in my class and you're like, I have no idea which form, you can always ask me, say, do you want this reduced? And I'll say yes, or I'll say no, I'd like you to answer this question, which will not be reduced. So just ask lots of questions. And you know, if this video is a little bit weird because I'm answering a specific question, but if you still have questions, please seek out friends, family, tutors, me, other mathematicians, math teachers. There's tons of people who can help, and we will work on answering that question. You guys are awesome. Woohoo. Math on.